These are the class notes for today, Wednesday, September 30th. So we're going to continue in that first video of Unit 4, and we're going to look at tables and write an equation for the transformation. When we write our equation, we are going to compare the changes in x and the changes in y. And we're writing the function h of x in terms of f of x. So what that means is, because we don't know what kind of function this is, we don't know if we're looking at quadratics, at absolute value. So when we write our equation, we're going to write it as h of x equals, and it equals f, and we're going to write our transformations inside for h and k. So let's go ahead and begin. So when we're looking at x from here to here, what is the change we see? So we go from -2 to +1, and if you're looking at a number line, that is 3 hops to the right on the traditional standard number line. That would be 3 hops to the right. So that means that h is 3. When we compare the y values, f of x to h of x, we don't see a change. So that would mean that k is 0. So the only transformation we have is from h, which is going to shift 3 units to the right. And when I write my equation, it will be written as f, and remember, when we're putting it on the inside, it appears to be the opposite because we're subtracting h. So inside of our parentheses, we're going to put x minus 3, and k is 0. You don't have to add it. You can add it, so you can write it as f of x minus 3, or we can add that 0. Let's look at our second example. And I encourage you to pause the video at any time to try to work it out and then see if your answer matches what we get. So we again begin by comparing x, and we notice that there is no change in our x values. So that would mean that h is 0. When we look at our k value, we're going from 3 and we're going down to -7. So looking at a number line, that means that we went down 10. And because we're going down, because if we look, our y values are getting smaller, that would be a -10. So when we substitute, we're going to substitute h, and we're going to substitute in k. So our only transformation is that it's going to move down 10 units. And our function rule will be f of x, you can put the 0, you don't have to, minus 10, or you could just say f of x minus 10. Okay, so we have one more. When we do our comparison, we notice that h shifts from -4 to -8. So the numbers are getting smaller and they're going down by 4. So that would mean that h is negative 4. Our k values appear to be increasing by 5. So k is 5. So our two transformations are, because h is negative, it's going to move left 4. And because k is positive, it moves up 5. And when we write our equation, we are really putting in x minus negative 4. And we know that when you subtract the negative, it changes to addition, which is why it appears to be the opposite in the equation. Okay, so the last piece of today's notes will be to transform graphs of two functions. So we have the function g of x. G of x is a transformation of f of x. And we're going to look at the equation, determine those transformations, and then move that graph. So when we look on the inside, it doesn't matter what kind of function it is, h will always be inside and it will always be the opposite. So h is negative 3. And because it's negative, we need to take this graph and move it to the left 3. The second thing I notice, so this is my h, is that k is negative 2. Now because k is negative 2, we also need to move it down 2. So the easiest way to move a graph is to choose a couple of points and shift those points. So I'm going to look at this point here, and I'm going to move it to the left 3, 1, 2, 3, down 2, 1, 2. And then I'm going to do the same thing with this point. I'm going to move it to the left 3, 1, 2, 3, down 2, 1, 2. And we can kind of see that this is what we get when we take that graph and we transform it. Let's look at this second graph. The second graph is telling us to move to the right 5 because h is positive 5. So we're moving right 5. And because k is 20, positive 20, we are moving up 20. Now we need to be careful when we look at this one because the graph is scaled differently. If we look here, notice that our x-axis is counting by 5s and our y value is counting by 20. So when I'm moving something to the right 5, it's only one square. And when I go up 20, that's also one square. So just always look to see how is your graph being scaled, because it won't always be graphed or scaled traditionally by ones. So I'm ready to go ahead and do my transformation. And again, I'm going to identify a couple of points here to help me do it. And see, I'm going to just transform a few of these points. So when I'm looking at this first one, I'm moving to the right 5. So it's moving to the right 5, which is 1 and up 20. So that's what it appears like. And then here, and we can't fit that last piece, but we know that it is increasing. And that would be our transformation graph.